Hello friends, welcome to Awdhesh Academy. We have covered real numbers in our earlier lessons and today we'll be starting with polynomials. So first of all, let's begin with recapping all what you have studied in earlier classes because your textbooks will just say as you have studied in class 9th, but what if you didn't study at all? So let's first revise the earlier concepts. First of all, let's define an algebraic expression. An algebraic expression is a finite combination of constant variables, brackets and operators like 2x square plus 3x plus 6 suppose. Now here x square everything is variable. This term is a constant, that is its value is fixed. Here x may have any value, that is why it is called a variable. Now these are the operators. Here in place of the plus you can also have minus, divide, multiply, powers, etc. All these are operators. Now you can have any terms within the brackets. Let's say this and we multiply it by 4. So this was all about an algebraic expression, but our chapter is polynomials. So what is the difference between an algebraic expression and a polynomial? A polynomial is a subset or a subgroup of algebraic expression where there is basically two conditions for an algebraic expression to be a polynomial. First of all, the operators which are allowed in a polynomial are plus, minus, divide and multiply only. The second and the most important thing is the exponents have to be non-negative integers. That is, your exponents of the variable part particularly cannot have negative powers, that is your x, suppose 1 by x is not a polynomial because you can write it as x raised power minus 1, which would mean x has a negative power. So likewise we cannot have non-integral values as the exponents of x, that is we cannot have square roots, cube roots for x because this can be written as x raised power half and this can be written as x raised power 1 by 3. These are non-integral values, although these are positive. So all we have to keep in mind is it has to be non-negative, that is x cannot be in the denominator and x has to have integral powers, that is cube roots, square roots are not allowed. The next thing is, what is a term of an expression? Here people often get confused, like suppose we have 4xy plus 6x plus 3. Now a term is defined as whatever expression we have after the operators, that is this is one term, this is one term and this is one term. Don't get confused and say 4 is another term and xy is another term. This is not the case. The entire 4xy, that is whatever you have between the operators, are terms. Now polynomial is comprised of two terms, that is poly, which means many, and nomial means terms. So basically a polynomial is something which has many terms. Now many means what? How many? So if it has one term it would be called a monomial. Like for example we have 5x, 4xy, 2z, all these are monomials. Now suppose a polynomial has two terms, it is called a binomial. Bi means 2, like 3x plus 2, 4y plus 2z. These are binomials. Likewise, for 3 terms, we'll have trinomial. Tri, which means 3, like this was a trinomial. For other cases, generically, we'll say it is a polynomial. Now, the next thing is coefficients and degree. First of all, we'll see what are coefficients. Like in this expression, the constant term before the variable part is a coefficient. Like 4 is the coefficient of xy here. In this term, 6 is the coefficient of x. Remember, 3 is just a constant, it is not a coefficient. Like here, 5 is the coefficient of x, 4 is the coefficient of xy, 2 is the coefficient of z, and likewise we have 3 as a coefficient of x here, and 4 as a coefficient of y, and 2 as a coefficient of z. 2 here is a constant. Now suppose 3x plus 2. This is a polynomial of one variable because the only variable here is x. This expression, that is 4y plus 2z, has two variables, that is y and z, so we'll call it a polynomial in two variables. Here, for example, we have 4xy. X and y are two variables here, so we'll call it a polynomial of two variables. Likewise, we can have many such examples, like suppose we have 4xy plus 2z. This would be a polynomial of three variables, x, y and z. Now let's start with degree. So a degree of a polynomial is defined as the greatest of all the exponents of its various terms. Like suppose we had 3x plus 2. This has one variable and the power is 1. So the degree becomes 1. If we have 3x square plus 2x plus 3, this would be degree 2. Since the highest power of x here is 2. Here we have x's power as 1. So the degree of this polynomial will be 2. Now suppose we have this as an example. Here we have two variables, both have powers 1. So to calculate the degree, we'll add the powers of the individual variables here. Like 1 and 1, this term will have degree 2. Here the only variable is x and its power is 1. So here the power of the entire term is 1, here it is 0. Now the greatest of the exponents of various term, which is called a degree, it would be 2 here, since 2 is the greatest. So this polynomial will have degree 2. Now on the basis of the degree of a polynomial, we can have few classification. The first is a linear polynomial, that is which has a degree 1, like 3x plus 2 here had a degree 1 and this would be a linear polynomial. Likewise, these all here 5x, 2z are linear polynomial. Remember, 4xy is not a linear polynomial because we have two terms x and y, each have power 1, and so this is a quadratic polynomial, which is the next criteria. Again, this had a degree 2, so this polynomial will also be a quadratic polynomial. Another category is cubic polynomial. Cubic polynomial will have a degree 3. We don't have a cubic polynomial here, so let's write one. Suppose we have 3x cube plus 2y plus 3. This would be a cubic polynomial since the degree is 3. Now the next very important topic is algebraic identities. Now do remember all these identities because it will be essential in the further chapters of equations, etc. Now let's take the identities one by one and see how can they be used. The first is a plus b the whole square. Now this bracket can be written as a plus b into a plus b. If you multiply the brackets, you will get a square plus ab. Now multiplying it by b, we will get ab and then b square. So ab and ab will give us 2ab and it will be b square. So a plus b the whole square becomes a square plus 2ab plus b square. Now if we have a minus b the whole square, now this will be nothing but writing a plus minus b the whole square. So the derivation will be the same as like this, and a minus b the whole square will become a square minus 2ab plus b square. The only change will be here. So this was our second identity. The third is a minus b into a plus b. Now let's multiply the two brackets. First, a into a would be a square, a into b would be plus ab, minus b here, and a would be minus ab, and minus b into b would be minus b square. As you can see, these two terms get cancelled out and we get a square minus b square. So this gives us the third identity, which is a minus b into a plus b. This would be a square minus b square. This is a very useful identity. These were the identities where we had squares. Now what if we have a plus b the whole cube? Now we have learned to find a plus b the whole square. We can write this as a plus b into a plus b the whole square. So we can write it as, and substitute the identity of a plus b the whole square, that is a square plus 2ab plus b square. Now multiplying this, we will get a into a square a cube plus a into 2ab, that is 2a square b. Now a into b square will give us ab square, b into a square will give us a square b, b into 2ab will give us 2ab square, and b into b square will give us b cube. Now this becomes a cube, the 2a square b here and the a square b here gives us 3a square b, and the ab square here and 2ab square here will give us 3ab square, and the b cube comes here. So a plus b the whole cube becomes a cube plus 3a square b plus 3ab square plus b cube. Now the fourth identity for a minus b the whole cube can be derived in a similar way by using a minus b into a minus b the whole square. This can be replaced from the identity here, and multiplying the brackets will give you a cube minus 3a square b plus 3ab square minus b cube. Both of these identities here can be summed up as a plus b the whole cube is equal to a cube plus b cube plus 3ab into a plus b. For the fourth identity, for a minus b the whole cube, we can write it as a cube minus b cube minus 3ab into a minus b. So now the signs becomes easier to remember. Like for plus here, we have plus here and plus here. For minus here, we have minus, minus and minus here. So this way it becomes easier to remember. The sixth identity comes from the earlier identity which we have done, that is a plus b the whole cube, which was a cube plus b cube plus 3ab into a plus b. From here, if we take a cube plus b cube on one side and take this part on the other side, we will get a plus b the whole cube minus 3ab into a plus b. Now from here we can take a plus b as common and we will get a plus b the whole square minus 3ab. Now this would be a plus b into, opening this bracket using the earlier identity, we will get a square plus b square plus 2ab minus 3ab. So this would give us a plus b into a square plus b square, and this, the subtraction would give us minus ab. So a cube plus b cube is a plus b into a square plus b square minus ab. Now in the same way we can find our seventh identity for a cube minus b cube, which would be a minus b into a square plus b square plus ab. This can be derived in the similar way. The derivations which we are doing right now is not that important for your exams point of view. The usage and the identities are very important to you. The next very important identity is for a plus b plus c the whole square. Now this would be a square plus b square plus c square plus 2 into ab plus bc plus ca. In case you have minus here or here, all you can do is write it as a plus minus b and minus c to derive the whole identity in the same way. You don't have to memorize each and every conditions of this identity. Just memorize the basic one and you can find the rest of the identities. The last but not the least is the identity for a cube plus b cube plus c cube minus 3abc. This is equal to a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca. A special case of this identity is when a plus b plus c is 0. So when a plus b plus c is 0, this whole part becomes 0 and multiplication by 0 of any part will give us 0. So a cube plus b cube plus c cube minus 3abc becomes 0, or a cube plus b cube plus c cube becomes 3abc. So this part of the identity is also very important. So that was all about the basics of algebra and polynomials. I hope you have revised your concepts of earlier chapters well and now are pumped up to learn the new things of the class 10th polynomials. So we'll start with the new lessons from the next video onwards. Thank you for watching. Goodbye.